So remember in my last video when I said I fixed my mill? Turns out some of those fixes were a little less permanent than I expected. This is particularly not good because I have 2 jobs that I need to ship tomorrow. One of the jobs is half done, but I still need to prove out another part on that job before it can ship. And I have another job that I haven't even started yet that's got some tricky machining on it. And unfortunately, the machining on that job is too tricky to put in the Tormach because it requires a long reach half diameter end mill. So it needs to go onto the Haas, which is currently non-functional. Okay, it is sporadically functional. That issue that we had with the spindle wiring that I thought I fixed, turns out I made it worse. I did not help it. And when it was running this last program, it kept airing out and the problem's gotten worse and worse and worse. It's almost like electrical tape wasn't the way to fix it. I don't want to be rushing tomorrow to get these parts out at the last minute because that's a good way to make mistakes. So today we are going to fix the machine. We are going to finish off those copper parts, and then we are going to at least get a good start on the part that uses the tiny tools. Did I mention it's already 10 p.m.? So I think step 1 is to get the cover off the machine again and see if we can address that spindle cable issue. So this is the error I'm getting, spindle cable fault. And if we look up in there, that little bundle of tape there is the spindle connector, the spindle wires connector, and that is causing our issue. So we need to get that fixed. So unfortunately, I don't have a better idea of how to fix this than what the original owners did. So as embarrassing as it is, I'm gonna put this thing back together with zip ties. I'm gonna try to do it a little bit more even than they did. I'm gonna put basically a collar around the top and the bottom, and then use zip ties to like cinch it together. Kind of like I did with the spring in the last video, if you saw that one. So I'm gonna make these little collars, jacking zip ties in. So the first ones are basically just to hold these zip ties in place, and then these zip ties will put compression on this fitting. And I'm gonna do 3 of them as evenly around this as I can go. So I'm not putting any torsional forces. Just axial is what we're going for here. Though access is obviously kind of an issue. Whoever buys this machine from me whenever I decide to sell it is gonna wonder why I'm using such brightly colored zip ties. All right, so with our 3 tension zip ties loosely in there, I can now tighten our collars. And now tighten our tension zip ties. I am not proud of this, but sometimes you gotta do what you gotta do. And I need to make parts, so ugly zip tie solutions it is. If I had a better one, I would use it. That zip tie's gone. All right, let's see if this works. All right, the machine is back on and homed. The only way I can think of to test this is to just kind of tap on the table some. So I'm gonna lay my camera down here and we'll see if it turns on the red light. Before it was doing this, it was triggering at the drop of a hat. Well, it'll work or it won't, we'll find out. Hopefully we can finish off this program now without any issue and I can move on to other parts. Hopefully that does it and we don't have any more issues tonight. That would be awesome because I really need to get the part that's in here done and then move on to some other parts. I need to make 2 of these. These each have 2 ops, both of which aren't too bad, but I think 20, 25 minutes each. And then the other one, I haven't actually programmed yet, even though it's due tomorrow. That one will probably take about an hour for each op. I think I only need to make 1 of them. But here we go. No, you're not cold. Here we go. Cool. That's better. All right, well, it might air cut for a bit here, but eventually it'll find the material. And while that's running, I'm gonna work on programming the next part. I was sure I had broken a tool, but it's just a little stubby ball mill. Anyway, first part is done. I'm gonna check the outside dimensions and everything before I take it out of here. But this was the easy part. This shouldn't have any issues. We have to flip it over, and that's where we're gonna hit issues. It's the next day. I did not do a good job about getting video last night. I ended up not actually staying in the shop that long because I was able to get one of my parts done pretty quickly, and I figured it would be more efficient just to work on the other one today. This part I only need to make one of. It's not that bad of a part, except it's got two kind of difficult features. First feature requires this lovely little dovetail cutter. This is a 1/16 inch diameter dovetail cutter, and I have never used any sort of dovetail, much less one this small. So we'll see how that goes. The other feature requires these lovely long reach 20 thou end mills. Actually, they're 0.5 millimeter, which is about 20 thou. I've done smaller ones and I've done longer ones before, but these things are always scary. I think for the dovetail cutter, my biggest battle is going to be coolant access. So I'm actually going to use this little Harvey tool solid ER long nose thingy that I got for a previous job. And I'm thinking this will just give me better coolant access without me having to do a really long stick out. So we'll see. This Harvey thing gets pretty good run out, especially once I get it dialed in on the machine. So I think it'll work well here. I don't think it's going to add any undesired factors. I don't know if that last shot was in frame. Sorry if it wasn't. All right, we are ready for the sketchy part. We were on feed hold for a second there. Now we're going to bring out the tool. All right, I only have one of these tools. Let's slow down rapids. Let's slow down feed rate a little bit if we're starting off here. We're going. Did we make it? The tool's in one piece. That implies we have a groove. I'll have to figure out how to measure that in a second here, but all right, we did the hard part. I love it when things like that go right on the first try. The slot is out of spec, unfortunately. It's a little bit too wide at the top. And I think what's happening is the length of the tool was a little bit off. Again, we're pretty close, but we're like 1 thou or 2 thou off, or 1 thou or 2 thou oversized over my tolerance. And I think what's happening is the tool, which is wedge shape, is cutting too far up, which is eating into the top width of my slot, if that makes sense. Here, so my slot looks something like this, and my tool looks something, I don't know, like this. We'll do dotted line for the tool. So there's my tool inside my slot. Now, theoretically, those are approximately the same size. The problem is if I'm measuring this distance right here, and that needs to be in spec. So if my tool gets moved upwards, it basically wedges its way in, cutting off some of these sides here. So I think I need to move my tool down a bit, and that'll make this neck here narrow. On the bright side, everything else looks and checks good. I basically just need to run it a second time with some really minor cam changes, and we should be able to move that one onto Op 2. Well, second attempt is underway. Hopefully this one works out better, because I am running out of time. I think I probably can afford to make it one more time after this one, but if I have to make it 4 times, then I am out of luck and the part will be late. Redoing this part has actually kind of worked out. Looking at my cam again, I realized that there was a hole that I needed to drill that I was planning on drilling in the other operation, but that hole was at the bottom of another hole. And because of the ring that comes on these little PCB drills, I actually wouldn't have been able to get to the bottom of that hole. So it's easier to drill that hole from this side, from the Op 1 side. So we didn't scrap a part, we just revised our production method. You don't break tools, you just make free dowel pins. Okay, now it's time for some teeny tiny drilling. I've already got the coolant aligned, so I know it's hitting the right place, just need to run it. Please don't scrap my part, Mr. Drill. So I'm holding Op 2 of this part in soft jaws. I have my jaw set up here in my flux vise. I have a spacer in there so that there is room to tighten the vise after I cut the soft jaws. Obviously, I could do this in a vise, but honestly, soft jaws are quicker and easier than trying to pick up a new work coordinate system without a probe using the wiggler here, and it's more precise. And honestly, I just don't want to screw up this part, and this is a more reliable method for me. Now, I have used these soft jaws like 6 different times in this location. I think this part might finally do it in, but there should still be enough material here to make a good set. When I first got this flux vise, I was worried that I'd be spending too much money on soft jaws because that's all it uses, it just has soft jaws. But really, in practice, I use the same set of jaws over and over and over again. It amortizes out between different jobs. So I maybe spend like the equivalent of $5 worth of soft jaws per job, which really isn't a big deal when it compares to the other methods, which I'll either scrap a part that'd be worth more than $5, or it would just take me longer to get set up. I have a good cam template built up that pretty much covers 95% of like 95% of my soft jaws. So all I do is put the part in there, use a Boolean subtract, clean up anything that the model needs, and just regenerate the cam, and it gives me good tool paths. While that's running the soft jaws, there's our little 20 thou end mill, long reach. It's making a slot that's a little bit less than 1/4 inch deep. My customer on this one was like, "You're gonna need a wire EDM to machine this part." Proved you wrong. Maybe, I'll tell you in a slot later. So this job shop stuff is kind of messy. And like, I don't script these videos. I don't know what's gonna happen. And so sometimes these videos end up messy. So sorry for this being messy. Those parts I was working on, I had to rush, but I got them shipped on time. They went out right before FedEx closed. It's fine, they're to their customer, we're good. I would like to be able to show you guys more of the parts that I'm making, but all of my customers, except one we're gonna work on today, tend to be picky about what I show. Fortunately, this next job is not one of those customers, and I get to show you the whole thing, the whole part, all the cam, the drawings, the designs, everything. Sorry for some of the mayhem that happened earlier in this video. This is the part we're about to make today. To my understanding, this goes on a shaft and then interacts with an inductive sensor. Pretty low tolerance, nothing too fancy going on here. I just want to make it look nice for the customer. So we got a big hole in the top there. We need to profile the sides. There are fillets on both ends. And there is, of course, this little countersunk hole. That's going to be the hard part today. Everything else, pretty simple, pretty easy. If we go into our cam, you can see we're going to be making this out of 1-inch round stock, which is pretty close to our final diameter. If we run into any problems today, it's going to be with that. We'll be using our 3-jaw chuck fixture, or actually probably my ER40 fixture. We're gonna start with a 3D adaptive with a 1/4 inch foreflute just to remove most of the material. Then we are going to profile the outside with that same tool, bore out the inside again with the same tool, finish off the top, and then come in with a ball mill and do our fillets. The mill is warmed up right now, but it's still a little bit messy from my last job. I have a love-hate relationship with this door on this mill. I love how much access you get, that you can stand directly over your workpiece once that door is open. But if you let chips build up in here, it leaks. And you cannot blow those chips out and get them into the chip pan. If you use compressed air, they fall on the ground. If you let them build up, you get coolant on the ground. And so it's just kind of always a mess. I have found the best way to get this cleaned out is to use that shop vac. That's why I keep it right here between these two machines. So I can just drag this over and vacuum out the door here whenever I need to, whenever I start a new project, basically. In my last video, I mentioned that CNC Repairman helped me out a huge amount trying to get this machine back up and running. And continuing his trend of just being a super generous guy, he let me borrow his tool. He let me borrow his drawbar force measuring thingy. So I'm gonna see how much force this drawbar is pulling. I think it's supposed to be like 300 to 400 pounds or something like that. But I'm curious to see what the actual number is. This will tell me if I need to rebuild my drawbar, which I think I do, but I'm not sure yet. So we're at just under 300 PSI. I assume that converts directly 1-to-1 to pounds, but I'll have to ask the CNC repairman if that is how that works. It is definitely below 400, but I think that's still like at the bottom of the acceptable range. It's not outside of the acceptable range. Let's see if it changes if I do this a couple times. It was pretty consistent. Every time it was just barely below 300 pounds. I stand corrected. The spec is above 280. Those are the exact wording. And technically 290 is greater than 280. So it is in spec. Though I don't know if we would get any benefits of seeing if we can increase that some, but I think it's fine. I'm not going to worry about it right now. This is my stock for this project. This is 1215 mild steel. It is 1 inch in diameter. I'll probably have to cut a couple more pieces off to get all the parts that I need, but I have like 3 feet of it, so there's no risk in me running out. The customer simply specified mild steel. They didn't care what alloy. And there's a lot of alloys that can be considered mild steel. 1018 is by far the most common alloy of mild steel, followed maybe by A36. 1215 is a little bit harder than 1018, but it's also a little bit easier to machine and easier to get nicer finishes and longer tool life on. 1018 isn't bad to machine. This is just a little bit nicer. Some of you guys if some of you are more familiar with the knife world, there's a steel called 12L15. It gets used a lot in Damascus billets with like 1095. This is that, but it does not have the lead. The L, I think, is the difference. I'll be using one of my favorite setups, which is this adapter plate that I made for various lathe chucks. I use my 3-jaw on it, and I use this ER collet holder on it. Because this is 1 inch, I figured I might as well go with the ER. Now, I'm going to take several parts and just kind of shift my work coordinate system down as I go. And I think I'm going to be saw cutting the part off. I'm not going to be salami slicing it this time. In the past, to tighten this, I have used various wrenches like this one. I couldn't find my ER40 wrench the other day, and I remembered why today. When I was working on this machine, I don't remember what I was doing. I was like routing a cable or something. And I used my ER40 wrench to push that cable like through or try to get it to, navigate through a gap. And I dropped it into the casting of this thing. So that ER40 wrench is never coming out. It is now part of the machine. I am ashamed to say that the last couple times I've been using this ER40 fixture, I have been using these channel locks to open and close it. That means not only was I not able to get a consistent torque on here, but also I did kind of mar up the surface a little bit. That was bad. Don't do that. But check this thing out. This is an ER40 torque wrench adapter from Martin Precision, and it's just super nice. This will let me get consistent torques without ruining anything. Full disclosure, I did not buy this from Martin Precision. They sent it to me for free, but I would have bought it. This thing is a very nice tool. The build quality is good, and I think it's definitely worth the money. I have the XY coordinates of this fixture stored in my machine, but I don't set the Z coordinates permanently. I set that on a per part basis. So I'm just going to do my traditional use a shim to set the Z axis here. Now in retrospect, I probably could have put the machine here and then moved the material up until it was touching the tool and then tighten the fixture. And that would save me having to do this, which is, an extra 30 seconds or whatever of work. So that's grabbing, and that's my work coordinate system. And that should be the last step before we run the program. And I suppose we should make sure coolant is set up how we like it here. Maybe like that. That first part just finished up, and it doesn't look that bad. Finishes aren't awful. I'm seeing a little bit of a witness mark there. But overall, I am happy with that. Now I need to check dimension. While that was running, I whipped up a very quick and dirty drawing that just has the important dimensions on it. Customer did not supply a drawing. He said he didn't even care about tolerances. I'm doing everything to my shop tolerance of ±3, which should be not too bad with this part. There's only a couple of the dimensions that I can check right now with it on the machine here. This one right here is probably the easiest. So let's see, 0.8402. See if we have any taper. 0.8405, so 0.3 of taper. We are aiming for 0.837. So we are oversized by about 3 thou there. So I'm just gonna offset the tool wear and rerun that tool path. To measure this bore, I'm gonna use one of these expandy gauges. This is just to get a transfer measurement to, never mind, they don't expand enough. My only good way to measure depth on this right now is to use a pair of calipers. And that dimension is dead nuts, which makes sense considering both the top and the bottom were cut with the same tool. So at least within the resolution of my calipers, that is right on. So I'm just gonna rerun my finishing tool paths, and that should bring us to within tolerance. I just checked the part again, and it looks like we overdid the wear comp by about 1 thou, just a tad over 1 thou. And that is probably because this time we were just taking a spring pass. We weren't doing, a full, so there wasn't as much deflection in the tool as when it was taking the, the 5 thou off or whatever I had for the finishing pass. So I changed my code to add in a spring pass, so next time it'll all be closer to nominal. And while that was running, I cut another piece of material so that I could take this one out and saw cut it and run another one while this one was on the saw. I'm just gonna reload this, touch off my work coordinate system, and run the program again. I only need 5 of these, so we're not quite halfway done, but we're getting close. While the next part is running, I'm going to use the saw, the bandsaw here, to cut this part off of its material. And I'm just gonna stick a marker in here to catch it so I don't mar it up. This 1215 mild steel is the best cutting material I've ever put on this bandsaw. Oh, I still dropped it, but shouldn't be hurt. All right, time to do 5 more. We have our 5 little op1s done. Obviously, the next step is to remove that hat. But just in case you were curious, I recorded all of the outside, it's not quite a real diameter, but the outside width here. The largest part is 0.8363. The smallest part is 0.8358. I think that was the one I ran initially where I did 2 finishing passes. So the dimension as it is modeled in Fusion is 0.8366. So we're between 3 and 8 thou undersized, which is definitely not bad considering this machine is 18 years old and was used in a pretty harsh environment before this. The parts did get progressively larger as they went, with the first one being the smallest at the 0.8358, with the last one being at 0.8363 and the 2 before that being at 0.8362. Which is what you would expect. The machine is warming up, it's growing, and that's where that difference is coming. So again, for an 18-year-old machine that was probably like 45K, maybe 50K when it was new, it's doing a pretty good job for me. And in case you were curious, the other features I measured with calipers, and they all fluttered like up or down a thou, but were pretty much dead on nominal. Honestly, I think that has more to do with my measurement technique and in the fact that I was using calipers than the machine. I bet if I used a more precise tool, the results would be closer clumped. When these parts are all the way done, I'll be able to use some better measuring tools. So now it is time to move on to Op 2. I'm doing this in soft jaws, so I need to replace the jaws on my flux vise here and then get them cut. So I got the new soft jaws on there. Obviously these have been pretty heavily used, but I'm hoping my part will fit right there and just kind of go over that existing pocket. If that doesn't work, I can definitely go to the other side and put it there. And if that doesn't work, I actually have some new jaws that I could use, but I like to get as much life out of these as I can. That being said, I do have an idea on how to better use this flux vise, and hopefully I'll be able to get that set up soon. Look for a video on that. Well, there's not a lot of room on this side, but there is just barely enough to support it, so I think it'll be fine. I did scrap one part when I was machining them by not setting my Z height correctly, and so there's a teeny tiny bit of saw cut there. So obviously I can't ship this one, so this will be our setup part for this Op 2. Not a lot going on this operation, just removing the hat and doing fillets on the backside. Yeah, so those soft jaws don't work. Let's try that again. I just pulled this part off and it checked good. So I'm gonna have to run one more Op 1, but I'm gonna go ahead and knock out the rest of these Op 2s first. The only fix I made was I just moved the exact same geometry over, remade it. I did cut it a little bit deeper, I suppose. That's one difference I made, but I just got it out of that pocket. I tried to get greedy and save soft jaws. All I had to do was move it over. I do have my spacer still in on this side to keep the vise from torquing weirdly, but seems to be working pretty well. So I'm gonna go ahead and run the rest of them. I will check in with you guys in a minute. So soft jaws are done, but these parts have a problem. You can see it's in here right now. The problem is this can rotate like that. There's nothing to clock it left and right, and I couldn't think of a way of doing that with soft jaws. If the hole was going on the other side, it would be easy. I could use these little wings to locate it. But they're just like on the wrong side. Short of doing some sort of soft jaws that like this fits into, I couldn't think of a good way. So my first thought was to use something like this. This is just a little template that I laser cut to get it level. But after playing with it, it just wasn't working. So I'm gonna have to go old school and use my dial indicator and just make sure both of these are at the same Z height. And once they are, then I can run it. It'll be a little bit slow and annoying, but sometimes that's just what it takes to make a part. So we're gonna bore a hole and then make the cone and then finish the cone. All right, that was super quick and I think it came out really well. Need to just do it 4 times more now. Words order, go in. And with this green blinky light, we are done with this project.